Welcome to True Projects. In this video, we are going to explain about a project titled Network Traffic Prediction Model Incorporating Road Traffic Parameters Using Artificial Intelligence Methods in VANET. So now coming to the introduction part, forecasting network traffic within vehicular ad hoc networks VANET assumes paramount significance as it serves as a pivotal determinant in guaranteeing the seamless and dependable exchange of information among the vehicular entities traversing a roadways. The contemporary era has ushered in an era of unprecedented technological advancement, one in which artificial intelligence techniques are harnessed to construct intricate and redefined predictive models. These models, when brought to bear on the challenge of traffic prediction, offer the potential to revolutionize the capacity to anticipate traffic patterns with heightened precision. At the crux of this endeavor lies a fundamental element: the harnessing of real-time data gleaned from an array of sensors and communication apparatus strategically embedded within the vehicular fleet. These sensors and devices are snugly integrated into vehicles, enabling the collection and transmission of critical data that form the bedrock upon which reliable traffic forecasts are constructed. So now coming to the objective part for this project, the goal of creating a network traffic prediction model through the utilization of artificial intelligence techniques within the context of vehicular ad hoc network VANET is to substantially augment the overall effectiveness and dependability of communication amongst vehicles traversing the roadways. To expound further, these models are designed with a dual purpose in mind. Firstly, they seek to enhance the management of traffic flow and then mitigate congestion-related issues. Through the intricate analysis of real-time data sourced from both vehicles in the existing road infrastructure, artificial intelligence is leveraged to anticipate potential bottlenecks and traffic jams. It then proceeds to proactively propose alternative routes or employ innovative traffic management strategies to alleviate the gridlock, thereby enhancing the overall fluidity of vehicular movement. Secondly, and of no less significance, the imperative objective lies in the enhancement of safety within the VANET environment. The integration of AI into this network aims to fortify and bolster the safety measures taken by vehicles. This encompasses the utilization of AI-based predictive algorithms to anticipate potential hazards or unsafe driving conditions, thereby enabling timely warnings or interventions to prevent accidents and safeguard the well-being of both drivers and pedestrians alike. So now coming to the requirements part, here we have two types of requirements: the hardware requirements and the software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Seaborn for visualization are important. Second, here we have exploring the dataset. This module involves an in-depth explanation of analysis of the dataset. It is designed to gain insights into the data structure and identifying relevant features for this project. Third, data processing. Data processing is a crucial step in the field of data science and analytics. In this, first we have processing using Keras to categorical. Keras is an open source deep learning library that provides high-level neural networks API and is built on top of low-level numerical libraries like TensorFlow and Theano. It's commonly used for building and training deep learning models. Second, here we have processing using Pandas database. Pandas is a popular Python library for data manipulation and analysis. Fourth, here we have visualization using Seaborn and Matplotlib. This module utilizes Seaborn and Matplotlib libraries to create visualizations that aid in understanding data distribution and relationships between variables. Fifth, here we have label encoding using label encoder. Label encoding is a technique used in machine learning to convert categorical data into numerical formats so that it can be fed into machine learning algorithms that require numerical input. Sixth, here we have splitting the data to train and test for deep learning and taking X and Y for machine learning. Within this module, the data set is divided into training set and testing set. This purpose is used to segregate data for training machine learning models and evaluating their performance. Seventh, building the model. Coming to building model module, in this module, range of machine learning algorithms are used to build the model. Here in deep learning, first here we have the model which is named as CNN, which stands for Convolutional Neural Network, a deep learning architecture commonly used for image and video analysis. It uses convolutional layers to automatically learn features from the input data. Second, here we have CNN and LSTM. CNN and LSTM here stands for Convolutional Neural Network with long short-term memory. It combines CNN and LSTM layers in a neural network. It is useful for tasks involving sequences and spatial data like video analysis. Third, here we have LSTM, which stands for long short-term memory. It is a type of recurrent neural network architecture which is designed to capture long short-term dependencies in sequential data, making it suitable for tasks like natural language processing and time series prediction. And here then we have BILSTM, which stands for bidirectional long short-term memory. It is an extension of LSTM that processes input sequence in both forward and backward directions. Next, here we have RNN, which stands for recurrent neural network, which is a type of neural network designed for sequential data. Next, here we have GRU, which stands for gated recurrent unit. It is a type of another recurrent neural network, which is similar to LSTM, but with a simpler architecture, making it computationally more efficient. Next, here we have CNN with K-fold validation. Combines with convolutional neural networks with K-fold cross-validation. So here K-fold cross-validation is a technique which is used to access model performance by dividing the data into K subsets and holding and testing the model's K types. So now here in machine learning, first model we have random forest. So here in this we are having that it is an ensemble learning model that combines multiple decision trees to making predictions. And the second model here we have the decision tree. So decision tree is a tree-like model that represents decisions and their possible consequences. Next here we have KNN, which stands for K nearest neighbors, is a simple yet effective supervised machine learning algorithm which is used for classification and regression tasks. It is primarily used for classification but can also be adapted for regression problems. The next here we have support vector machine. It finds a hyperplane that separates data points into different classes, maximizing the margin between classes. Next here we have voting classifier. It combines the prediction from multiple algorithms and selects the majority vote as the final prediction. It proves the prediction accuracy by leveraging the strength of various models. And then 8, training the model. This involves teaching a machine learning or deep learning model using labeled data to make predictions or classifications. Next on 9th here we have building the model with voting classifier, since it gives better accuracy comparing with other models. Combining multiple machine learning models, that is classifiers or regressions, using a voting classifier to improve accuracy by aggregating the prediction. 10th here we have Flask framework with SQLite for sign up and sign in. Using the Flask web framework to create a web application, employing SQLite as a lightweight database to manage user registration, that is for sign up, and authentication, that is sign in. Next here we have importing the packages. We have already discussed about it, that bringing in necessary libraries or modules in your code to access their functionalities. Next, user gives input as feature values, collecting the input data, that is feature values from the user. And next here we have the given input is pre-processed from prediction, preparing the user provided data for use within the data trained model by performing necessary data processing steps such as scaling, encoding, or cleaning. Next here we have trained model is used for prediction, employing the machine learning model that has been previously trained to make predictions or classifications based on the pre-processed input data. And the last one, here we have final outcome is displayed through front end, presenting the model's prediction or result to the user through the graphical user interface or front end of your application, often in a user-friendly format or visualization. So now coming to the execution part. To execute the project, first we need to open the code folder. So here you can see that here we have a folder which is named as static. It consists of files and related to CSS, JavaScript and Bootstrap files. And the folder here named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Next here we have app.py file, which likely contains the information related to front-end logic. It include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML template. And here this is our dataset which is used in this project in the .csv format. Next here we have signup.db file, which appears to be the database file which is used to store the information. And here this is our notebook.ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. So now just copy the path from here Open the Anaconda prompt. Type the command cd, give a space and just paste the path over here, and now hit the enter button. And now type python app.py. And now hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browsers. Here I am using Chrome. And now hit the enter button. Here you can see that this is our home page. So now just click on sign up button. Here this is the registration form. So you have to enter your credentials over here. I have already done the registration over here, so I am clicking on sign in button. Just enter the username and the password which you have created while doing the registration, and now click on submit button. So here you can see that this is our welcome to dashboard. You just have to enter the credentials over here, that date, time, latitude, longitude, direction and all. So just click on today. It will enter the date and time over here, latitude and the longitude. Enter the direction, choose the direction which you want to choose. Here I am choosing inbound from town. And next here enter the road from here. Here I am choosing A1 road. And now enter the speed vehicle. Here I am choosing 85 speed. And now type the vehicle flow rate. So here I am entering the 2. And for the traffic concentration, again I am entering 2. Depending on the parameters you are entering over here, it will detect. So now just click on submit button, and by scrolling down below, here you can see the outcome that based on the speed and vehicle count you are entering over there, the network traffic is free of fuel. Let's check with another parameters. So let's see first about on the about button. Here you can see that we are having the different graphs over here with the different accuracy based on the models here we are using. Now just again go to home page. And now just enter the date and time over here. The same date and time will remain same. And just wait, let me enter the details over here. So now here you can see that I have entered all the details over here, the latitude, longitude, direction. Here I am choosing now this time the outbound from town. And here I have chosen the road, that is A13. And here I have entered the vehicle speed, flow rate and the traffic concentration. Let's click on submit button and let's see the outcome. So the outcome is based on the speed and traffic vehicle count, the place you have entered over there, the network traffic is congested. So now again let's try with another example. Now again click on home button, scroll down below and let me enter the details over here. Now here you can see that I have entered all the details over here, and now here you can see that again I have chosen the direction again. Now this time I have chosen the inbound from direction, and here I have chosen the road, that is A4. Vehicle speed I have entered over here 78, vehicle flow rate is 111 and traffic concentration is 0. And now just click on submit button. By scrolling down below, here you can see that the outcome is showing based on the speed and vehicle count, the network traffic is congested. So now let's again try with another example. So now here you can see that I have entered all the details over here. Here you can see the direction is outbound, the road is B40, vehicle speed 69, vehicle flow rate is 133 and traffic congestion is 0, concentration is 0. So now just click on submit button, and by scrolling down below, let's see again it is showing that the network traffic is congested over here. So by clicking on the sign out button, here you can simply log out with this. So now coming back to the conclusion part. In conclusion, the integration of artificial intelligence techniques to predict network traffic within vehicular ad hoc network BANET with a particular emphasis on road traffic parameters signifies a substantial stride towards enhancing the intelligence and efficiency of our transportation systems. The infusion of artificial intelligence into BANETs to forecast network traffic is in harmony with the overarching movement to make transportation systems more intelligent and adaptable. As technology advances and evolves, these AI-powered traffic prediction models are poised to assume a central role in shaping the trajectory of vehicular communication and transportation systems in the future. These developments represent a promising avenue for not only optimizing traffic management, but also for achieving more sustainable and responsive transportation infrastructures that benefit both the economy and society as a whole. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.